Hello, my name is Teteje Kepsi Richie and welcome to my YouTube channel. Today our discussion on partial differential equation will be solving first order partial differential equation using the method of separation of variables. So we learn how to solve partial differential equations using Lagrange and using the geometric method. Please, if you have not watched any of those my videos, please check it on YouTube. Today we will talk about the separation of variables. Separation of variables is used to solve any order of a partial differential equation. However, today our attention will be focused on only first order partial differential equations. So before the lesson will end, I will tell you the idea behind the separation of variables. Then we'll take some sample questions and find solutions to them using the method of separation of variables. This will be a very interesting discussion. Please watch the video till the end. So the idea behind the separation of variables is that we assume that the general solution to our first order partial differential equation or to the partial differential equation is the product function of the two variables involved. The product of the function of the variables involved. For instance, the variables involved here are x and y. So we assume that the solution to this partial differential equation is equal to a function of x multiplying a function of y. That is it. What happened? Now we will find the partial differentiation of u with respect to s because it's here for this. Find the partial differentiation of u with respect to y for this. Then you substitute. After you substitute, your partial differential equation will become an easy separable ordinary differential equation. That is how it works. So now let's do that. So we say we find the partial differentiation of u with respect to x. So this will be equal to, so the y will be kept constant. So we say x prime y. Then we find the partial differentiation of u with respect to y. So our x will be kept constant. So we say y prime x. What happened? You substitute this into your partial differential equation. Then it will become a very separable ordinary differential equation. Then it's solved. Now let's substitute and see. So we have a, in place of partial differentiation of u with respect to x, we put this. So x prime y, then plus b. In place of partial differentiation of u with respect to y, we put this y prime x equal to 0. So we can send this here and separate it. So let's see how we separate this. We have ax prime y equal to negative b y prime x. We divide both sides by x y, here by xy. So this will divide that. We have ax prime over x equal to negative b, the x will also divide, so negative b y prime over y. And you equate it to a constant, say k, or any other thing. People use lambda, it's the same thing. Now you equate each of these to the constant. So we have ax prime over x equal to k, then negative by prime over y equal to k. What happened? You divide both sides by the constant. So here by a, you have x prime over x equal to k over a. Then this one too, we have y prime over y equal to negative k over b. When I divide both sides by negative b. Then, what happens? This becomes an ordinary differential equation which you can easily integrate both sides. So you can write this as 1 over x prime, then we integrate, equal to the integral of k over a dx. The same thing to this one too. 1 over y prime, the integral of that equal to integral of negative k over b dy. Then you find x after integrating. Find y after integrating. Then you substitute them back into this. You substitute them back into this to get the general solution to our first order partial differential equation. So this is the idea behind the separation of variables. Now we'll take a sample question and I will take you through how we do that. So let's solve our first question. It says, find the general solution to the partial differential equation below using the method of separation of variables. So you can't jump quickly in using Lagrange or geometry. It's a method of separation of variables. You are limited. So let's go. We said that the idea is that the general solution to this is a product function of the variables involved. So that's. Then remember, for the sake of time, let me write this like this so that it will be fast. Now I can find the partial differentiation of u with respect to x. So I said del u over del x. So our y will be kept constant. So we have x prime y. The differential of x times the y. Then I'll find the partial differentiation of u with respect to y. So the x will be kept constant. So we have y prime x. What next? We substitute the partial differentiation into our partial differential equations. Then it will become separable. It will become an ordinary separable differential equation. So now let's substitute since we know the partial differentiation. So we have 4, in place of del u over del x, we put x prime y minus 3. In place of del u over del y, we put y prime s and equate it to 0. We have 4x prime y equal to 3y prime s. Now we divide both sides by x over y, xy. So our y will divide, we have 4x prime over x equal to, the x will also divide. So we have 3y prime over y, then equal to a constant, say, k. Now we equate each of these to the constant, then solve. So let's equate this. We have 4x prime over s will be equal to a constant, say, k. What do? We can divide both sides by the constant 4. So we have x prime over s is equal to k over 4. So you can have 1 over x prime equal to k over 4. Then we integrate both sides. We have the integral of this dx. Now when we integrate 1 over s, please, this x prime is the same as the dx. So when we integrate, you know how the integral, the form that integral takes. So when we integrate 1 over s, we get ln x, and to equal to, this is just constant. So it's just the attachment of the variable to it, then plus our constant of integration. So we can find, ln is a log with a natural base e. So our s can be equal to e exponent k over 4x plus c. We can rewrite this as s equal to e exponent k over 4x times e exponent c. So now we let our e exponent c to be equal to maybe capital C1. Now in place of this, we substitute C1. So when we substitute the C1, we get s equal to C1. C1 will multiply this. E exponent k over 4s. Then this becomes our function, the x function. So the x function is C1, e exponent k over 4x. Now we equate the other one too. Remember, this is what we were having. So we equate this to k. So we can have 3y prime over y equal to k. We divide both sides by the constant 3. We have y prime over y equal to k over 3. So what do? We rewrite this as 1 over y prime equal to k over 3. Then we integrate both sides, dy. So when we integrate 1 over y, we'll get ln y equal to k over 3. The integral of this is just the attachment of the y. Then plus our constant of integration. So our y, remember again, will be equal to e exponent k over 3y plus c, which we can rewrite as y equal to e exponent k over 3y times e exponent c. So we'll let our e exponent c to be equal to capital C2, since we have C1 already. So our y will be equal to C2 e exponent k over 3y. So our y is equal to C2 e exponent, our function, our y function, will be equal to C2 e exponent k over 3y. So now we have found the two functions, y and what? X. So what do? We substitute it here. Since we said that the general solution should be the product of the function of the variables involved. So that's the next thing we do. So since we know the two functions, we substitute. So our general solution xy of this partial differential equation will be c1, that's the function of x, c1 k over 4 e exponent k over 4x times the y, which is c2 e exponent k over 3y. So since they are multiplying, we can write this as c1 c2, I'll let them multiply, e exponent k over 4s times e exponent k over 3y. See, we can use indices to rewrite this thing as the general solution to be u of s equal to c1 c2 e exponent k over 4s. Since they are multiplying with the same base, we add the exponent plus k over 3y. So if some boundary conditions are given to us, we substitute, get a value of c1 c2, get a value of k, then we'll get a particular solution to our partial differential equation. So this becomes the general solution to our first order partial differential equation. I hope you get that. We'll solve one more question where boundary conditions are given so that you'll be abreast with it. So let's solve our second question where some boundary conditions are given. They say find a particular solution to the partial differential equation below using the method of separation of variable, given that u of x0 is equal to 4 e exponent negative x. So separation of variable, remember, you said it employed the idea that the general solution is the product function of the variables involved. So you can say u of xy is equal to x of s, that's a function of x and a function of y. Okay, so for the sake of time, let me write it this way, x, y. So what do? We find the partial differentiation of u with respect to s. So u of x, y will be kept constant. So that will be x prime y. Then we find the partial differentiation of u with respect to y. So the partial differentiation of u with respect to y will be, so the s will be kept constant. So y prime s. What next? We substitute this into our partial differential equation. Then it will become separable. A separable ordinary differential equation for that matter. So let's do the substitution. We have 3 in place of the partial differentiation of u with respect to s, we put x prime y plus, in place of the, we put y prime x and equate it to 0. So 2, there is 2 y prime x. Then what do? We send this one. So we have 3 x prime y will be equal to negative 2 y prime x. What next? We can divide both sides by xy. Divide both sides by xy. So what will we have? We have 3, the y's will divide, so 3x prime over x equal to negative 2 y prime, the x will divide over y. Then we let this to be equal to any constant k or lambda. What next? You take each of these, equate it to k, and find the function of x and the y. So let's take the first one. So 3x prime over s is equal to k. We divide both sides by 3. Get x prime over s equal to k over 3. So we can rewrite this as 1 over s prime equal to k over 3. Then we integrate both sides, dx. So all integrate this, we'll have ln x equal to, this is constant, so k over 3 x, then plus our constant c. So remember this, our s will just be equal to e exponent k over 3s plus c, which can be rewritten as s equal to e exponent k over 3s dot e exponent c. So we'll let our e exponent c to be equal to capital C1. Okay, so we said e exponent c should be equal to C1. So we substitute our function x, okay, will be equal to C1. Let me bring the C1 first. E exponent k over 3x. So this becomes our function. So now we substitute these two to k to find the function of y. So we get negative 2y prime over y should be equal to k. We divide both sides by negative 2. We get y prime over y will be equal to negative k over 2. Can rewrite this as 1 over y prime equal to negative k over 2. Then we integrate both sides, dy. When we integrate this, what do we have? We'll have ln y is equal to negative k over 2y, then plus our constant c. So y will be equal to what? Y will be equal to e exponent negative k over 2y plus c, which can be rewritten as e exponent negative k over 2y times e exponent c. Okay, so what we do, we let our e exponent c to be equal to capital C2. Then our function of y will be equal to C2 e exponent negative k over 2y. Remember, we had the s to be this, the function of s. So we said s of n is equal to the C1 e exponent k over 3x. Now we assume that the general solution should be the product of the two functions, like this. So we just substitute. So our u of sy will be equal to, so this is this one. So C1 e exponent k over 3x times C2, this is that, e exponent negative k over 2y. So we can rewrite this as C1, C2, I just bring this one, e exponent k over 3x times e exponent negative k over 2y. So using indices, our general solution will be equal to C1, C2, e exponent k over 3x minus, I'll add, so minus k over 2y. So this is our general solution. However, remember some boundary conditions are given to us. Look at the boundary condition. Is here. U of x0 is equal to 4 e exponent negative x. So we substitute that into the general solution to get a particular solution. So we had our general solution. We substitute the boundary conditions. So in place of y, we put 0 and equate it to 4 e exponent negative x. So our u of x0 will be equal to C1, C2, e exponent k over 3x minus k over 2 times 0, and to be equal to what? 4 e exponent negative s. So what are we having? We have C1, C2, e exponent k over 3x, the whole of that will be 0, will be equal to 4 e exponent negative x. So when we reach there, we just compare. You see that the coefficient of this is C1, C2, and the coefficient of this is 4. It implies that our C1, C2 is equal to 4. Then the exponents are the same, so we can equate them. The bases are the same, so we can equate the exponent. We can say k over 3x, k over 3, the coefficient, because there is Sn, there is Sn. So k over 3 will equal to the coefficient there, -1. I hope you get that. What next? We'll find k by multiplying both sides by 3. K will just be equal to -3. So we substitute k equal to -3 into our general solution, this. Then C1, C2 equal to 4 into this. Then we get a particular solution. So we substitute, since we know that C1, C2 is 4 and k is equal to -3. So our particular solution, U of xy will be equal to, in place of C1, C2 we put 4. The E exponent, in place of k we put -3. So -3 over 3x minus -3 over 2y. I hope you get that. So U of xy will be equal to 4 E exponent -s. Look at that. 3 divided by 3 will be -1. Then this will be plus 3 over 2y. We can rewrite this. You can leave it like this, but let's rewrite it again. As for E exponent, I'll put the negative out. Then I'll write x minus 3 over 2y. Then this becomes the particular solution to this first order partial differential equation using the method of separation of variable. I hope this helps. Check out my videos on how to use the method of separation of variable to solve second order or higher order. Please remember to subscribe to the YouTube channel if you are here too, and click on the notification bell so that if I post a video, you'll be the first to receive it. Until we meet again, bye-bye.